This is part 2 of the study guide, and all I'm doing is be very careful here. Let me show you the wrong way to do this. Don't just square the r and then square the 3. This is part of the answer, but it's not the entire answer. If you want to get the real answer, okay, this is wrong. It's r plus 3 squared, so write that binomial twice. So you get r squared plus a 3r plus another 3r plus a 9. Again, by doing the distributive property, you'll notice that you get that. So this actually comes out to r squared plus 6r plus 9. Now, for the next one, I'm going to be doing this using the shortcut. The shortcut is this. You multiply the first terms, and you multiply the last terms. That gives you the beginning and end, right? To get the middle, you multiply, since it's the same thing by itself, you multiply these things by themselves, 3 times r, and you double that to get 6r. If you don't like, if that confuses you what I just said, you can just do it the long way, expand it out, and do the regular distributive property, and that will work. But I'll do the shortcut for the next one. So number 20 is a lot like the last one we did. I'll do that in a second. That's the one I'm going to use that shortcut for. Number 19, okay? This one's a different type, but you can still use a different shortcut. You can still FOIL it if you want, and you get k squared plus 3k, and then minus 3k, and then minus 9, and you'll notice that the middles cancel out, so you get k squared minus 9 for number 19. All right? Or if you recognize that they're conjugates means that they're the same binomial but an opposite sign, you can you can memorize that they cancel out, but just doing it the long way works. I'm going to do this one the shortcut way, okay? Instead of actually writing this out twice and following it, I'm going to show you the shortcut way. So I know that if I take this and I square it, I get 9d squared. If I take 10 and squared, I get plus 100. Now, the way I'm going to get this middle term, I'm going to do 3d times 10, and I'm going to double that. So that's 30d. Double that, you get 60d. That is the shortcut that I was talking about. But if you want to do it like I did number 18, where I just wrote it out twice and did the distributive property, you can do that if you prefer. There's no reason to force yourself to use that shortcut. Here's another example of that special case. I know the answer is going to be g squared minus 100. Now, the shortcut I'm using, because they're conjugates, you can write the plus 10g and the minus 10g, like if you do it the regular way, and they will cancel out. But either way, it'll eventually simplify. 22, I'm going to use this as a squaring a binomial. So I can square the 2m, which is 4m squared. I can square the negative 7, and negative 7 times the negative 7 is a positive 49. Then I can double the product of 2m times negative 7. This is negative 14m. If you double that, you get negative 28m. So that's using the little shortcut there. And if you want, you can just expand them both and do the distributive property. For 23, okay, this time I'm just going to avoid using shortcuts, even though I totally can, but I'm going to do this the long way. That's 7 times 7 is 49, so that's 49h squared, and then this is plus 14h, and then I'm going to distribute the negative 2 to each one. Negative 2 times 7 is negative 14h, and then minus 4 by multiplying those. Notice how the middle cancels out, so you get 49h squared minus 4. For number 24, we're just using an expression to represent a side length. So let's look at this. So we got a birdhouse, and it's a square. And I'm going to draw sort of a square. It doesn't have to be perfect. But so we got 3x minus 4, and then 3x minus 4. How do I know that's both sides? Well, it's because it's a square. Well, what polynomial represents the area? Well, area is, you multiply base times height, length times width, or in a square, you multiply a side times itself. So it's 3x minus 4, and we square it, or you can think of it as 3x minus 4 times 3x minus 4. These are the same thing. Either way you do it, you should still put it in standard form, which means like, you like multiply it out. So that's 9x squared. And then we got minus 12x minus another 12x and then plus 16. And then you simplify these x terms to get 9x squared minus 24x plus 16. And that's your final answer. Okay, for number 25, I want you to understand what makes a polynomial a polynomial. So when we say, can the degree be negative? Now, I'm going to draw a distinction here. We talked about in last chapter things like x to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared, so on and so forth. But even though these things exist, these are not polynomials. So polynomials are just sort of like a subset of, x to a certain power, but we only like to use the positive powers to call polynomials because they behave a certain way and they have certain properties, and these things don't obey all of those properties. Specifically, that if you put 0 into x, it breaks this. You can't divide by 0. If you put 0 into x here, it still breaks it. You divide by 0. Polynomials, however, you can put any number in front of the x, like inside of the x, not just in front of the x, and it doesn't like break the math. So the answer to this is no, because for a, and I'm saying polynomial, doesn't matter if you say polynomial or monomial. For a monomial or polynomial, you can only have degrees that are whole numbers. So specifically, you can actually have a degree of 0, 1, 2, 3, and then so forth. And the reason why we say degree of 0 is okay, say you have x to the 0, that's just 1. So that's like a constant term. So that's fine, but you can't have negative degrees of polynomials. You can have a 0 degree and it still technically behaves like a polynomial. But negative degrees are bad. Negative degrees are bad. And we call these, just in case you're curious, when you do have a negative degree, these things right here, we often call them reciprocal functions, or sometimes they're sort of a subset of rational functions. Basically, they're functions that have an x in the denominator because weird things happen. Now, I'm going to show you, you don't need to be familiar with the graphs of these yet, but polynomials, like for instance, x squared, we know that's a parabola shape, okay? X cubed, you might be less familiar with. It's like got this sort of like disco man shape, okay? But if you take even x to the 0, it's just, now it's a straight line. It's not as curvy, but still, you can put any x in here and it doesn't like break the math. Like you can put any x and it doesn't change the value. But now let's look at negative degrees. Whoa, look at that. Okay, notice how when we try to set x equal to 0, like you don't have to know why, but you never get there. But basically it's that you can't divide by 0. Remember that x to the negative 1 is the same thing as 1 over x. So if I type 1 over x, that red line is the same as the purple one. So that's why you can't have negative degrees in polynomials. X to the negative 2 looks a little different. Okay, and it's because like they both go up for a reason, and this is actually really neat if you just have all of these graphed together, makes these cool little patterns. But just remember that polynomials don't have negative degrees, and the short answer, if you want a reason, is because just look at how weird the graphs behave at 0. They do weird things whenever you have a 0 in the denominator. That's why we don't like having negative degrees, because it puts a variable in the bottom. We're going to do another area problem because we're so used to multiplying polynomials. Now, the problem is we want to find the area of this shaded region right here, okay? Well, it's not exactly, it's rectangular-like shaped, but we have two rectangles. Like, it would be a lot easier if they just asked us to find the area of like this whole rectangle. But the problem is we don't want the area of this rectangle that's in the middle of that. Well, what is the shaded part? Notice how the shaded part is part of that big rectangle, but it's not including the red. So how would you calculate it? Well, you should do the big rectangle minus the small rectangle. So find the area of the big rectangle, which is x base times height, or height times base, x plus 3 times x plus 6. Then subtract from that the area of the small rectangle, which is x minus 4 times x minus 2. In case you're curious, the order doesn't matter. Like, I could easily write these backwards. I could easily write x plus 6 first and x plus 3. It actually doesn't change the answer of the product because multiplication, remember, is commutative. So, but this comes out to x squared plus, I'm going to actually shortcut this. There's a 3x and then there's a 6x, so that's going to be 9x. And then multiply the 6 and the 3 and get 18. Minus, and here's where I want to be careful. I want to subtract this whole result. So I'm going to subtract the result of this is x squared. It's a minus 4x, but also a minus 2x, so that's minus 6x. And negative 4 times negative 2 is positive 8. I want to subtract all of this. So if I do x squared minus x squared, well, you just get 0x squared, so there's none. But instead of being like I can make a mistake here, I might do 9x minus 6x. It's like, wait, I don't want to do minus 6x. You need to do 9x minus negative 6x. That's just too much for me. I'd rather just change the sign on all these so I'm less likely to make a mistake. So now it's more like, oh, instead of subtract negative 6x, it's add 6x and 9x, so I get 15x. Remember, these x squareds canceled out, okay? So I get the 15x right there by adding the 9x and the 6x. And then 18 plus negative 8. Well, that's like 18 minus 8. So that's a 10. So I get 15x plus. And that represents the area of this shaded part. Okay, for 27, we're going to practice building a question instead of just solving it, just to make sure you understand factoring. So we're going to write a trinomial that has 9x squared as its greatest common factor. Now, the way I'm going to do that is I'm going to actually write 9x squared, and I'm going to write some stuff in parentheses. And what's important is the stuff I write in parentheses doesn't have any of the factors in common. So I'll write, like, let's do 2, and then let's do 5, and let's do 7. Those are all prime numbers. Yeah, you could choose other numbers that are what we call relatively prime. But I'm making sure that they're not all even numbers, they're not all divided by 5, they're not all divisible by 7. And then, but the problem is if I added these together, that wouldn't be a trinomial. These would just add together, and then that would multiply, and you'd actually get a monomial. So I got to put some variation. This is a 7, that's cool, but let's make this, can't make this a 5, let's make it a 5x. Now these can't be combined. Oh, well, let's make this an x squared. Now these can't be combined. So this is the answer unsimplified, but to write the trinomial that has that, I can just distribute it. So I get 18x to the 4th plus 45x plus 63x squared. And there's millions of different answers to this. This is not by any means the only answer to this. You could have chosen any numbers here. You could have done x to the 4th, x to the, well, yeah, you could have done x to the 4th, and then x, and then a 7 like that, and that would have been fine, as long as they don't all three have an x in this case, because we want the x squared to be the highest degree of the common factor. For 28, we want to write something that has a GCF of 1. Okay, what that means is that none of the terms will have really any meaningful greatest common factor. So they'll be relatively prime. So let's take numbers like, let's go with 10. That's an even number. It's divisible by 2 and 5. Let's take the number 13. Okay, it's not divisible by 2 or 5. And let's take the number, now let me try the number 45. Oh, that wouldn't be good because 10 and 45 have a common factor of 5. Okay, so let's try 42 instead, Okay, great, that works out. It's not divisible by 13. It's not divisible by 10. It's not divisible by 5. It's not divisible by, oh, it is divisible by 2. Oh no, so I can't choose another even number. So I can't use 42 either. All right, so let me choose a different number. What if I use 43? 43 will work out. So these would give you your numbers. Now, we want it to be a trinomial, so I could do like I did last time, where I have this is x and this is x squared. And that would normally be okay, but they added an extra condition. It has to be of degree 4. So instead of having the highest degree being a second degree, I'm going to put a 4 right there. And then there I have a trinomial, 3 terms, 1, 2, 3. The greatest common factor is 1 because of all these numbers, the only thing they're all divisible by is 1. That's the biggest number they're all divisible by. And there isn't even a common x in all of these. I don't want to put like, it would be bad to put x squared here and x here, because in the GCF you could pull an x out. I don't want to be able to pull anything out, so this would be one possible answer. Okay, so 29. If n represents an even number, we want to write a simplified expression that represents the product of the next two even numbers. Okay, so let's record what this is. So n is an even number. All right. Now, what we don't understand, maybe, like, what do I mean the product of the next two even numbers? Well, let's look what the next number would be. So it helps to maybe give an example. Pick any even number. It doesn't matter what number you pick. I'm just going to choose a number like 10, okay? So what would the next number that is even after 10 be? Well, that would be 12. Okay, so how do you get from 10 to 12? Well, to get from one even number to another, you always add 2. Oh, okay, so this would be the next even number. But they said the next two even numbers. So this is the next even number. What's the next one after that? Well, that would be 14. Well, I could say that's n plus 2 plus 2, or I could just say that's n plus 4. This is like the first, the 12, the n plus 2 is like the immediate next even number. The n plus 4 is the next even number. So when we want the next two even numbers, that means we want to multiply the immediate next number times the next number. And we want the product. Product means multiply. So we want to do n plus 2 times n plus 4. And we just, do the little distributive property. So that's n squared plus 6n plus 8. I did the 6n really quick by doing the 4 and the 2n, adding them together. But this is the expression. I mean, you could check to see if the expression works out. All right, if your even number would happen to be 10, okay, then 12 plus 14 would give you 28. But if you plug that into this expression, it would still work out to the same thing. And this would work out for whichever even number you chose. It would still work out. I mistakenly said 12 plus 14, which would give you, the sum would give you 26, but we want the product. But if you took 12 times 14 and you multiplied those, and then remember 10 represents the original number. If you put 10 right here, right? Put 10 right here, that would be 10 plus 2 is 12. 10 plus 4 is 14. That would still give you 12 times 14. And this would just be the simplified version of that. It's in standard. For the last one, we want to describe how to simplify this polynomial expression in standard form. Well, here's the first thing I would do. So the first step I'd do is this. I would change the subtraction sign to addition. And you can even write that in symbols, change the subtraction to a plus. And this doesn't have to be your first step. Your answers can vary, but that would be a good idea. Then there's only really one other step. You just combine like terms. Now I'm writing it in a list form because, there's steps to this, and I find it makes it easier to read. You could write it in a complete sentence with conjunction if you want. You could say, first change, subtraction to addition, comma, then combine like terms if you'd like. But I just choose to do it this way. I just care that you can organize your thoughts. So we describe how we're going to do it, but then let's actually do it. So the 8k squared, I can combine that with the 4k squared, which would give you 12k squared. Now there's no k cubed term here, but there is one here. So I'm actually, instead of having to rewrite this and reorder it, I'm going to write it in front there. Because standard form means you put your highest powers first and your lower powers all the way at the end. So I've already accounted for this. Combine those. I've accounted for the negative k cubed. All right, now we have a positive 1k, a positive 7k. We can combine those. And that I took care of those. Now we have a negative 1, and remember I changed this to addition, negative 1 plus a negative 15, so that gives you negative 16. So this is your final answer in standard form. Okay, that's the end of the study guide. Good luck.